Hello everyone, my name is Bun Pen Yang, a sophomore student, major in civil engineering at Paragon International University. In today's video, I'm going to cover a point from a chapter called Applications of Definite Integral. This chapter was taken from a course called Math 132 Calculus 2. The point that I'm going to cover is arc length. So let's moving on to the video. Before moving on to the video, we have to know what is arc length. So the definition of the arc length is the distance between 2 points along a section of a curve. As we know the definition already, we can move on to the formula. So there are two formulas for the arc length. For the first one is arc length equal to integral from a to b square root of 1 plus f prime of x squared dx. So in this case, we can use this formula if only y is equal to f of x. And as we know that in this video, I'm going to try to obtain this formula by using the curve that was given. For y equal to f of x from x equal a to x equal b. As we see that we try to find the length of this blue curve right here, which is start from point A to point B. But we cannot find it directly, so we have to use a line segment to approximate the area of this curve. As you can see that in each curve we draw one line segment from A to B. In each curve we have this line segment. So we're going to obtain the formula by using this line segment right here. As you can see, by using the Pythagorean theorem, the length of the curve of the line segment is Lk equal to the square root of delta xk squared plus delta yk squared. How do we get this? As we know that this is the line of segment of the curve. So delta yk is the interchange of the y-axis and delta xk is the interchange of the x-axis. As we draw a interchange line segment, we created a triangle. So we can compute the formula right here by using the Pythagorean theorem. So in order to obtain the formula that we want, we have to first factorize the equation. In this case, we only factorize the delta xk squared because we say that y equal to f of x. So we only factorize the delta xk squared. As you can see, as we factorize it, we get 1 plus delta yk squared over delta xk squared, which leave it to this get out of the square root is the delta xk, and the remaining result inside the square root is 1 plus delta yk over delta xk squared. The reason why we can put it in one square right here because it's the same. And after that, we got the limit approach to infinite sigma of Lk. We can obtain the formula right here. Integral of from a to b square root 1 plus f prime of x squared dx. And for another case is we have to deal with discontinuity in dy over dx. In this case, for x equal to g of y from y is equal c to y is equal d. So it's the opposite of the first case. For the first case is the x-axis and this case is the y-axis. We compute it in the same way as before, except we use the y-axis instead. So as you can see, this is the interchange of the y-axis, delta y, and down here is the interchange of the x-axis. By computing the Pythagorean theorem, we can obtain the same result, which is Lk equal to the square root of delta xk squared plus delta yk squared. It is going through the same process as the x-axis as well. The same as before, we have to factorize the equation. So we got the Lk is equal to the square root of delta yk squared and plus 1 plus delta xk squared over delta yk squared. So in this case, we don't factorize the delta xk square. In this part, we only factorize the delta yk square. So as you can see, this is the result after we factorize it. As you know, the delta y squared cancel the root, so it's becoming delta yk. After that, we got the same result as before. We got the L equal to integral from c to d of 1 plus dx over dy squared. Instead of the first one, the x-axis, which is dy over dx squared. But for the y-axis, it's different by this part. It is dx over dy squared. And now let's moving on to the example so that you can understand the formula better. So the first formula is the fx equal to 2x over 3 over 2. So what I mean by that, so in this part, we were given the f of x, which means we have to use the first formula, which is L equal to integral from a to b of square root 1 plus delta y over delta x squared. Right here, and so that we calculate the arc length of the graph of the fx over the interval 0, 1. So we had to calculate the arc length from 0 to 1. And here's the solution. So as you can see, here's the first formula. L is equal to square root of 1 plus f prime of x squared dx. So the given f of x is 2x over 3 over 2, and we have to derivative the f of x. We get 3x 1 over 2. So in this case, we just try to find the f prime of x squared already, so we just put it in the square root. We obtain 9x. So the arc length is square root of 1 plus 9 of x. But we cannot solve this example directly, so we have to let u equal to 1 plus 9x. So finding the u is 9dx over the interval of from 0 to 1. So the formula else right here, by substituting the data that we got else is equal to 1 over 9 integral from 0 to 1 square root of u du. As we compute, we will get the answer right here. We just have to get it off the integral, and the result is 2.26x. For the second example, it's the opposite of the first one, which is this time it was giving the x instead. So let's go over the example 2. Let x equal to y cubed over 3 plus 1 over 4y. Calculate the arc length of the graph of gy's over the interval 1 to 3. As you can see, I already draw the graph right here, so you can see the arc, what the arc looks like. So we have to calculate the arc of this length over the interval from 1 to 3. And here is the solution. So the formula that we're going to use is L equal to 1 is equal to square root of 1 plus g prime of y squared dy. Gy is already given, which is the x, so it's the same thing. X is equal to g of y. So g of y is equal to y cubic over 3 plus 1 over 4y. So we put it in the derivative. We get y squared minus 1 over 4y squared. As before, it's the same as before. We need the g prime of y squared, so we just put it in this, in the square. We obtain y over 4 plus 1 over 2 plus 1 over 16 y over 4. And we know that we got the interval 1 to 3. So the arc length is, we just have to substitute the data that we got. We can see that L is equal to integral from 1 to 3 square root of 1 plus 4 plus y4 minus 1 over 2 plus 1 over 16 y4 dy. And we have to calculate this 1 plus minus 1 over 2, so we get integral from 1 to 3 square root 4 plus 1 over 2 plus 1 over 16 y4 dy. And we can put this in the square, so we obtain the y squared plus 1 over 4y squared, and we cancel this square. We can obtain the result, which is 53 over 6. And that is it for the result, as we going through the how to find each formula from the curve and also each example for each formula. And thank you for your attention.